Okay, and again, all of the lectures or WebEx meetings, at least since the midterm, are on that YouTube channel. And so if you want to do any missed assignments, you can probably find the associated video and watch the steps to do it if you want to do anything you've missed. Okay, so if you go to the final exam for spring 2020, I've posted there a practice exam and the solution, so we'll go over that, and then after we're done with that, I will post your final, which you'll have to send via email, and that's due next Monday. All right, so we can open up the practice final, and then we'll go to the solution. Okay, so your final will have 5 questions that'll be similar to this practice exam. So you have number 1 will be on the cost regression 2. Where we did the multiple regression with the multiple plants. Number 2 will be on the cost regression 3, where you did the multiple regression with the binary variables that had, this one has the multiple plants, and the other one, question number 1, that has the multiple products. Okay, number 3 will be on the hardware sales, where you did the exponential smoothing and moving average. So this will be similar to what you did for this one, and what I had you guys do for that forecasting assignment. All right, so you should be familiar with these concepts. And then the last 2, 4 and 5. All right, so 4 will be on chapter 10, which was on the simulation models. The ordering counters one, all right, and so I have two problems on that, and so basically 3 questions on chapter 14, I think it is. Yeah, 3 questions on chapter 14, and then 2 questions on chapter 10, which we did most recently with the simulation model. So here's the practice exam, and we'll go through this right now, but the one you're going to see is going to be similar, 5 questions, same types of examples. Okay, so let's open up the one that I put my solutions on, so we can go through this will be our review for the final. Okay, number 1 was the estimating total cost for several products. All right, so you'll get a screen cap for the data, and then a screen cap for the regression results, similar to what we did for this example. Okay, and so part A is look at the screen caps and using the data. What you're just going to do here is write the multiple regression equation out using the coefficients from the data analysis. Okay, so we did a regression with similar to in class. So we did total cost as a function or has a relationship with three different types of units A, B, and C. And so we're going to analyze the specific effect of the different units. All right, so what's your multiple regression equation using the estimated coefficients? And all you got to do is use the general equation and plug in the coefficients, right, which are right there. Okay, so the general equation is total cost is a function of those three things and the intercept. So total cost equals the intercept, which is this coefficient there. Okay, plus the coefficient for unit A, which is 790 times unit A, and then plus the coefficient for unit B, which is 956 times unit B, and then finally plus the coefficients for unit C, which is 731 times unit C. So this is the the effect of each of the variables on total cost. So this is the effect of all the separate units. And you can see that it looks like unit B is the most costly to produce, but there's a separate cost or separate average cost for each of the separate units. Okay, part B is what's the interpretation of the R square and the coefficients for units A, B, and C. Alright, so the R square is 0.95. You can see that up here. Okay, you should recall that that is the percent of explained variation for the independent variable. In this case, that's total cost. Alright, so just interpret that decimal as a percent explained. So in this case, it's 95%. So approximately 95% of the variation in total cost is explained by this multiple regression. Alright, and so then you get to interpret the three coefficients, which are essentially the average total cost of each of the separate types of products. Alright, so here's the coefficients for units A, B, and C: 7.90, 9.56, and 7.31. I put those down here to talk about those. Alright, so the one for unit A, that's on average how much it costs. This is what happens to total cost. So total cost goes up by this amount each time you produce one unit A. So this is basically the average cost of producing one unit of product A. So it costs, in dollar terms, $7.90 to produce one unit of product A on average, and then the same for unit B. That's the cost in dollars. Costs $9.56 to produce one unit of product B on average, and then the same analysis for unit C. That's the cheapest one. Costs $7.31 to produce one unit of product C on average. So you can see the breakdown of the different costs. So they're not all the same costs, and this tells you the estimated cost. All right, last part for number 1, calculate total cost for month 15. So to estimate total cost, we need an estimate or a projection of how many units of each we're going to produce. So in month 16, we think we're going to produce 450 units A, 660 units of B, and 504 units of C. All right, so let's plug those into our equation, and we can estimate our total cost based on how many each type we think we're going to produce. All right, so if it's for month 16, plug these ones in. If it was for month 17, you would plug these ones in, but just use the general equation and then plug in the estimates or the projections for the x variables, and that'll give you your estimated total cost. So we're going to plug in 450, 660, and 540 for how many of each we think we're going to produce, and then that'll give us the estimate of the total cost. All right, so here it is. The total cost for month 16 is the intercept. All right, so we're using this general equation. And then plugging in those values for units A, B, and C for month 16. Okay, so total cost for month 16 is the intercept 8,740 and 4 cents plus 790 times 450. Units of A, plus 956 times 660 units of B, and then plus 731 times 540 units of C. All right, and if you just add all these together, the total projected cost comes out to looks like 22,552 and 4 cents. And make sure that when you get the total cost, that it's in the right range. So you can see the total cost up here. All right, so we got 22,000, something that seems right. So all these costs here are 30,000, 20,000, 17,000. So if you get something reasonable, it's probably right. So if I came out with my total cost of being like 500,000 or something like negative 20, if it's something that doesn't seem right, then double check the math, because it should be something in the range of these other total costs. So that looks right. Okay, so that's number 1. Questions on this one? All right, let's go on to the second one, number 2. Okay, so now we have the 3 different plants, and this is from cost regression 3. And so let's look at the screen caps for that. This one you only get you only need the summary output for this one. Okay, so look at the screen cap here, and then using data analysis, we estimated multiple regression with total cost as a dependent variable, and this time we have the different plants. So there's units produced, and then there's plants 2 and plant 3 as the 3 independent variables. And recall that remember, since these are binary, that we don't include all 3 binaries, because the case when plant 2 and plant 3 are both 0, that defaults to plant 1. So you only need minus 1 of the total binary variables. So plant 1 is when plant 2 and plant 3 are both 0. Okay, so what is our equation with the coefficients? That's the first part. All right, so there's your coefficients. Just put those into your general form, showing the effect of the x variables on total cost. All right, total cost equals the intercept, which is 8,867, plus the effective units produced, which is 41, times units produced, plus the coefficient for plant 2, which is 5,187, times plant 2, and then minus, this one is minus 5,993 for plant 3, times plant 3. All right, so again, when plant 2 and plant 3 are both 0, those things go away, and then we're automatically at plant 1. All right, part B, what's the interpretation of the coefficients for units produced plant 2 and plant 3? Okay, so the first one is the same type of interpretation, but the plant 2 and plant 3, those are binary variables, meaning they're just 1 or 0. So explain the case when those are 1. All right, so there's your coefficients for units produced. 41, plant 2, 5,187, and plant 3, which is negative 5,993. So let's explain those. All right, so for units produced, that's just how much it costs on average to produce a unit, right? If total cost goes up by 41, then it usually costs us, so we can expect it to cost us $41 to produce one unit. So it costs $41 to produce one unit on average, but the plants, these are binary, so this is the case when we're only producing at plant 2. And you can see that the total cost goes up, right? And remember, this is relative to the plant 1 situation. So this is the cost increase where we start. So it just costs this much more to produce at plant 2. So total cost is 5,187 higher at plant 2, and that's compared to plant 1. Okay, plant 3 you can see is less than plant 1, so we start a little bit lower. So this is the total cost is this much less at plant 3. Total cost is 5,987 lower at plant 3 compared to plant 1. Okay, so make sure you interpret these in relation to the other case, which is plant 1. So these are all in addition or in subtraction of what happened at plant 1. Okay, and then C is what is the unique intercept for each plant. And I think we did this. I'm not sure which practice problems we had time to get to in class, but if we didn't do this one, you can see that this is how you calculate the intercept for each of the plants. And so just going with the logic that plant 1 is when the other two are 0, this should explain how you get the separate intercept. Okay, so the intercept for plant 1 is just the intercept you see in the chart, because when plant 2 and plant 3 are 0, then this is the only intercept left. And so the default one is the intercept for plant 1. Okay, and so like we discussed, plant 2 is this much more than plant 1. And so all you have to do is add this amount to the plant 1 intercept. So this plus this is the intercept for plant 2, which is higher. All right, so 8,867 for plant 1 plus the additional amount for plant 2 gives us an intercept for plant 2 of $14,054. Not dollars. $14,054. All right, and then for plant 3, we explained already that it was lower than plant 1. So if that's the case, just start with plant 1, 8,867, and subtract the coefficient for plant 3. All right, so this minus this is the intercept for plant 3. So that's 8,867 minus 5,993, which gives us the plant 3 intercept of 2,874. All right, so that's number 2. Any questions on this one and how to get the intercepts? All right, let's go to the next one, which is number 3, and this is on the hardware sales one, where we did the moving average and the exponential smoothing from chapter 14. And so let's, part A is look at the screen cap for hardware sales. And using a moving average, just calculate the week 105 sales forecast using an MA2, moving average of 2, and then also a moving average of 3. So both specifications. All right, so the first screen cap is for the moving average part. And then all you want is the two blank, the highlighted cells that are missing. So you want the week 105 moving average for 2, and then week 105 moving average for 3. All right, and this next one is for the exponential smoothing, so we'll get to that in part B. All right, so to get a moving average of 2 for your prediction, all you do is take the average of the last 2 actual observations. All right, so it's basically the average of week 103 plus week 104, which is $95.15 plus $85.10. All right, so if you add those two together and take the average, which is just divide by 2, then you get a moving average of 2 for your next month, week 105, which comes out to $90.13. All right, so a moving average of 3. Now you want to take the average of the last 3 pieces of data. So just throw in the week 102 to your average calculation. All right, so now you want the average of these last 3, which is 82.90. plus 95 plus 15 plus 8510. So the average of week 102, week 103, and week 104 sales data. All right, and so there it is, 82.90 plus 9515 plus 8510, and then average of 3 is just divide by those 3. Divide by 3, and it gives you a moving average of about $87.72. All right, so for the moving averages, you just need the sales data to do your calculations. You don't need to use, so these moving average of 2 and 3, you're just taking the average of the sales data, so your calculation doesn't have to do with the actual moving average 2 and 3 you see here, so just average the sales data. All right, so part B is look at the exponential smoothing screen cap, and then let's get the week 105 sales forecast using an alpha equals 0.8, and then also using an alpha of 0.9. Alright, so there's the general formula for exponential smoothing, and so it's just alpha times the last piece of data plus 1 minus alpha times the last forecast. Okay, so there's your screen cap for the exponential smoothing. Alright, let's start with the alpha equals 0.8, and so that means that our this L is just I just took that from the general formula. So the LT, T is the time, so L105 is the week 105 forecast. Okay, so it's alpha, which is 0.8 times the last observation. Alright. So in week 104, the sales was 8510. And then plus 1 minus alpha, so you should know that, or see that 1 minus alpha, 1 minus 0.8 has got to be 0.2. So 0.2 times the last moving average in the 0.8 process. Alright, so the week 104 for that is 93.68. Okay, so if you do this simple calculation, you get for your alpha equals 0.8, your prediction is 86.87. I'm sorry, 86.82. Alright, so same process, but different alpha for 0.9. So the L105 for the 0.9 is alpha 0.9 times, again, the last observation, which is 8510, and then plus 1 minus alpha, which is 0.1. 1 minus 0.9 is 0.1, and then that's times the last forecast in this process, which is 94.22. Alright, and this comes out to $86.01. And so again, for all these, make sure that your answers are within a reasonable range. See, all the sales data is like, somewhere between 50 and like 150, and so make sure that your forecasts are somewhere in that range. So if you get something ridiculous, then double check the math, because you should get something close to what happened recently in your answers for the forecast. All right, so part C, what does the alpha do specifically in an exponential smoothing model? And remember, the alpha, you know exactly what it does. If you increase it, it puts more weight. The weighted part goes more to what just happened in the last observation or piece of data. So increasing alpha simply puts more weight on the previous observation by doing that. Okay, and then part D, what exponential smoothing model would you use if your historical data had a upward or downward trend? Right, so if you had a trend, you can use a more sophisticated model that we did in chapter 14, or what if your data had a seasonal pattern that kind of repeated? So remember we did the soft drink sales, which went up in the summer and down in the winter due to increased demand in hot weather, and then lower demand in colder weather. All right, so for the trend, remember we did it in the example, we used Holt's linear trend. All right, so there's that one, and then for the seasonal, there's a model we use called the Holt-Winters, the Holt-Winters model, which captured seasonal aspects of data, and so those are the two we use. In that example, if our data had a trend, Holt's linear trend, or a seasonal, which was the Holt-Winters model. All right, so questions on number 3 here? Okay, let's do number 4. And so we're moving to chapter 10 now, and these are the simulation ones. So this is one of the ones we did last week with the ordering calendars simulation example from chapter 10. All right, so let's look at the screen cap of ordering calendars, Excel only model 1, and what is the demand for replication 1 only. So obviously you don't have to do the simulation, but I just want you to know how to do one of the simulations, so then you see how it gets repeated. So first, how does Excel figure out what demand to use based on the lookup table? So what's demand for replication 1? All right, so all you want to do here is look at, so here's the first simulation, which is the only one you have to focus on. And then there's the random number. And so the random number will tell you what the demand's going to be. All right, so Excel, we would do like a lookup table here, or VLOOKUP. And to understand how VLOOKUP works, it's pretty simple. It looks up this number and goes up here and gives us the demand that goes along with that number. So remember, these are the ranges, the cumulative probabilities. So if it's basically if it's less than 0.3, demand is 100. If it's between 0.3 and 0.9, 0.3 and 0.5, it's 150. If it's between 0.5 and 0.8, it's 200. If it's between 0.8 and 0.95, it's 250. And then if it's above 0.95, it is 300. So these ranges give us the associated probabilities. So there's only a 5% chance it's 300. So that's why all the numbers in the top 5 percentile go to this number. So you can see that if it's 0.91, that means it's in that range. It's bigger than 0.8 but less than 0.9. So that gives us a demand which would be reported as 250. Okay, so look at the random number, then go up to the table, and then find the demand that the VLOOKUP function would give you. In this case, it's in the range that would give us 250 for demand. All right, then part B is calculate the revenue, ordering cost, and refund for replication 1 only. All right, so with that demand, what is our revenue, cost, and what's the refund, if any? Okay, so revenue is the price we sell the calendars at. Okay, which is $15, and then you multiply it by, so it depends on your order quantity and your demand. So let's look at the two. So demand is 250, and we ordered 200. So obviously we didn't meet demand. All right, so we can only sell the ones we ordered. All right, so demand exceeds the order quantity by 50, but because we only ordered 200, we only get to sell the 200. So basically, profit is the price times 200. So it's 15 times 200 because we didn't order enough to meet the extra 50 demand. Okay, so revenue is 200 times 15, which gives us a revenue of 3,000 for this example. Okay, all right, so we'll get to the refund, but do you see how we get the revenue first? Okay. And then the cost, so we'll do the cost and then we'll do the refund. So the cost, this one's the easiest because it's just the order number times the cost to order. So if we order 200 and it costs us, the unit cost is 5 per calendar, and it's just 200 times 5. So order quantity times unit cost is always the cost, so it's 200 times 5. Oh, so how do we find demand again? So, okay, so alright, so I'll do I'll do demand again, and then we'll get to the refund, because that's coming next. So demand, look at the random number, 0.91. Okay, and then go up to the lookup table and find the demand that would come along with the VLOOKUP function. So Excel would find 0.91, and see 0.91 is in between these two numbers, 0.8 and 0.95. And so that means that if demand is within this range, right, if it's 0.8 to 0.95, that gives you the demand of 250. So it's based on the random number because we want to make sure we cover the associated probability. So look at the random number, then look at the cumulative probabilities and report the demand that goes with 0.91. All right? Do we see that? Okay, you're welcome. All right, so we got the order quantity of 200 times 5, which is 1,000, and then the refund, okay, so this depends on if we have extra calendars or if we don't. So the refund amount is $1. Okay, so if we get refunds, they're $1 per calendar. And so if we ordered extra, so if we ordered too many, then we can get a refund. But in this case, see that order quantity is 200 and demand is 250. So we didn't even meet demand, so we don't have any extra calendars to get a refund. In fact, we'd like to have more. So we wish we would have ordered more, but we didn't. So we don't get any refund because we don't have any left. So if we don't meet demand, then we don't get a refund. It's only if we have extra calendars, basically if we overshoot demand. So the refund amount is 1, but there's no refund to give because we don't have any calendars left over. So the refund is 0. Okay, you're welcome. All right, so then the profit is always it's the revenue minus the cost, and if we had a refund, we would get that back, but we don't. But I'll put that in there anyway. All right, so part C is calculate the profit for replication 1 only. So profit is just revenue minus cost plus any refund if applicable. Okay, so profit is revenue of 3,000 minus cost of 1,000, and then plus I put the refund of 0 just to have it in the formula. So if we had a refund, we would get 0, or we would get it, but in this case it's 0. So it's just 3,000 minus 1,000, which is 2,000. Okay, so part D is just look at the data table in the cluster column for average profit versus order quantity, and which order quantity gives us the highest average profit. So in class we did this whole analysis where we looked at is 200 going to give us the highest, is the average order quantity going to give us the highest average profit? And so sometimes it did and sometimes it didn't. So in this case, just look at the table and the chart. Okay, this one, and so all you have to do here is look at the both things. So which value or which order quantity gave us the highest average profit for this simulation? You can see that it looks like this one, 200. So you can go confirm in over here. So these are the order quantities and the average profits. All right, so just go through and see that over here, just confirm what you saw on the chart. So 200 gives us the highest average profit of 1,453 and 30 cents. So all you have to say here is order quantity 200 gave us the highest average profit for this simulation. Okay, so we got one more kind of like this, but any questions on what we did here for demand, revenue, cost, refund, or any of this stuff? All right, so I think this one will have a refund, so you can see the other case where we have too much as opposed to too little like last time. Okay, so part A is just look at the uh, what's the demand for replication 1. So look at the random number, go to the table, and find the demand. All right, so random number is 0.3, and I tried not to make it exactly on the boundary, which in this case I guess I did, which is 0.3. And so just know that if it's like, so like I said, if it's between 0.0 and 0.3, it's 100. But if it's 0.3 or higher, then it goes to 150. So if it's the actual number, like 0.0 or 0.3 or 0.5, it goes to the number that's right next to it. So if it's exactly 0.3, the demand's going to be 150. Okay, so that's easy. If it's exactly the number, just look at the demand next to it. Okay, so a random number of 0.3 gives us a demand from the table of 150. Okay, now we want revenue, ordering cost, and refund for this replication. So everything is with a demand now of 150. Okay, you can see the unit price is $3, so that's the price we sell them at. Okay, so the revenue is $3 per unit, and then times how many we sold. Okay, so you got to compare demand and order quantity here. So demand is 150. We ordered 200, but demand was only 150, so we can only tell what demand is in this case. So we only sold 150 because the extra 50, there wasn't enough demand, so we only sold the 150. So it's the minimum of order quantity and demand in this case. Remember last time we didn't order enough. Or last time we ordered too many, or last time we didn't order enough. This time we ordered too many. So we only get to sell to 150 because that's all demand is. So it's $3 times 150. And that gives us a revenue of 450. So make sure you compare on the exam what demand and what order quantity is, and you can only get revenue for the minimum of the two, because if you order too many, you only get what demand is, and if you don't order enough, then you only get what you order. So double check that you're choosing the right value for either demand or order quantity. All right, so in this case, 3 times 150, which is 450. Okay, unit cost is $1. That's how much we pay, and we ordered 200, so this one's easy. Unit cost times order quantity is just $1 times 200, which is 200. And here we do get a refund because we ordered too many. So the refund amount is 50 cents. And you want to compare order quantity and demand. So we ordered 200. Demand was only 150, so we have 50 less, right? So we Demand, we ordered 200, we sold 150, and that means we have 50 left. There wasn't enough demand, and so we can get a refund for the surplus of 50 at 50 cents per calendar. So 50 cents times 50 is $25. So notice how I have the other example where we didn't get a refund, and this one where we did because we ordered 50 extra calendars, and we can't sell them to the customers because it wasn't high enough demand, but we can get some refund back from the wholesaler at 50 cents per calendar. All right, and then you just want to get the profit for replication one. So this is the same formula, revenue minus cost plus refund, but in this case, we do have a refund, so we have to add that in. Okay, so profit is a revenue of 450 minus the cost of 200, and then we get a refund back of $25. So this comes out to 275. All right, so revenue minus cost plus refund is always your profit calculation. Okay, then let's look at the data table and the clustered column screen cap, average profit versus order quantity, and what order quantity in this case gives us the highest average profit. And so this one's easy. I just wanted to make sure you understand what we're doing with the simulation analysis. So just go down to the table and the chart. Okay, so which one order quantity gave us the highest value? It looks like it's 250. You can confirm that over here. Where, yeah, that's the highest one. So just look through if you want to double check, just look through the average profits and which order quantity gave us the highest average profit. In this case, it was 250. Okay, so here we shouldn't order 200. Like the average said, we should instead order 250 to get us the highest average profit, and that's by doing all the simulations based on the logic you just did for simulation 1. All right, so any questions on this type of example, getting the demand, or the demand, the revenue, and the refund? I think are the three things that you want to make sure that you know how to do. So you see to get demand from the random number. You see that revenue depends on which is smaller, order quantity and demand, and you see that refund depends on if you order too many calendars or you don't. All right, so everybody good on this one? I guess we've gone through the whole practice exam, so any questions on anything we've done? Okay, why is revenue not 200 times 3? Oh, because so you ordered 200, right? But demand was only 150. So you can only sell what demand is. So because even though you ordered, like last time we got to sell everything we ordered because demand was higher. And so if we order 200, but only 150 people buy the calendars, then we only get the revenue from those customers. So we don't get to sell the extra 50 because demand for the product wasn't high enough. You're welcome. All right, so any more on this problem? Okay, so give me a second. I'm going to post your final exam to the Blackboard page. So one second, and I'll post that for you guys. Okay, so there you go. If you go to the on the Blackboard page, if you go to the final exam spring 2020 section, there's the practice exam we just did, and then here is your final exam, which is due next Monday. Okay, so it tells you when it's due, which is Monday, May 25th. Okay, and it's due by email, just like the previous midterm too. And so whenever you don't have to wait until the last minute unless you have other things to do, but whenever you're done with this, you can email it to me at the same email address. And again, make sure the exam for sure, and then any assignments that you still have to do have to be done by the date of Monday, May 25th. And then again, we'll do, let me post this here. All right, so like I said, the final date to submit all assignments is Monday, May 25th. So that includes the final and any assignments that go to the Blackboard page. And then Wednesday this week, we will do an extra credit example, which is also due on Monday, May 25th. And so unless you've done and plan on doing every single assignment that we've done so far, you might as well do the extra credit one because that'll count for an extra any missed assignments that's occurred throughout the semester. Okay, so all right, so here's your final. It'll look similar to what we did just now in the practice exam. So you got 5 questions. That's due next Monday. Okay, so everybody good before we wrap up today's session? Okay, so that's it for this morning. Finals due in a week. Any assignments, including the ones from anything after midterm 2, is due Monday, May 25th, along with the finals. And then on Wednesday, we'll do an extra credit assignment. And it'll be just like a normal assignment, except it'll be extra credit. And yeah. All right, so let me know if you have any questions on the final. And I will see most of you on Wednesday at the same time. And everyone stay safe. And thanks for joining. See you guys soon.